All right, well, good to see everybody. Thank you for being here, and thank you again to the Energy Drone and Robotics Coalition for giving us all the opportunity to talk about these topics and related to methane strategies and methane applications and all the different technologies that are swirling around the kind of detection and visualization of hydrocarbon gases, and mainly being here the topic of methane. So my name is Jeff Lake, and I'm the Vice President of Sales for Sierra Olympia Technologies. We're based out of the Hood River, Oregon area, and we're a manufacturer of thermal imaging camera systems, mid-wave, long-wave, and short-wave infrared systems. And we do specialty cameras, and one of those specialty cameras is the topic we're going to talk about today, which is called an optical gas imaging camera that just about everybody in this audience is probably very familiar with. So our company was established in 1995. Our president, Chris Johnston, started the company actually in Seattle, Washington. And then around 2010, actually, we moved down to Hood River, Oregon, right on the banks of the Columbia River between Washington State and Oregon. If you go down to bullet point number 4, we had to have a name change that went into effect at the beginning of this year. There's an exclusion area in the United States for the ability to use the word Olympic. And when we moved down to Hood River, was probably nobody ever did any kind of name checks or that sort of thing, but we wanted to do some trademarking, and when we started that process, the United States Olympic Committee contacted us and said, oh, by the way, you're not in the Seattle, Washington area where you can use the word Olympic. And so we had to change the name of the company to Sierra Olympia Technologies. So we're still the same company and have been around all of this time. Moving on from there, the topic here that we're going to discuss, or I'm going to discuss, is the real-world applications for methane and hydrocarbon emissions and compliance as it relates to handheld portable OGI cameras for crewed or uncrewed systems, manned, unmanned, or drones. And then OGI cameras for ground robots that obviously down on the show floor and the expo floor, we're seeing a lot more robots these days, and they are a thing that is going to be happening in the future. And then finally, optical gas imaging for fixed-mounted continuous monitoring. So it's been discussed all morning from the various panels and everything about Quad OA and the current standard that has been in place for a number of years now. And for OGI, that standard is 60 grams per hour, and it's a 50-50 mixture of methane and propane. That kind of equates to about 10,000 ppm, and it's using a 1/4-inch orifice. So this is the current regulation that's been in place that we've been using OGI cameras for many years. So the new proposed rules of Quad OB and Quad OC are looking to target 17 grams per hour for methane and or 18.5 grams for butane. And that would be at 2 meters. You'd have to be able to do that with an OGI camera. And then also at a delta T of around 5 degrees centigrade, and then at 1 meter per second. So that is the proposed basically rule that is going to potentially go into place with Quad OB. That's already been established by the United Nations in OGMP 2. That is what they are going to do, and that applies pretty much to the rest of the world. So one of the things that we've been working on, and we have a kind of an independent company that's evaluating and making sure and validating that just like we did for Quad OA, that our cameras will be able to meet these new rules. That will be very important. So us as a manufacturer, we're jumping out in front of that and making sure that we're going to be in compliance or validated for that, and industry can obviously start using it immediately when these rules go into place. It's also been talked about earlier for the super emitters. Those are at the 100 kilograms per hour for methane. And then it gives you standards about when you have to be able to fix those once you've identified them. Okay. Our technology, what we refer to, our cameras are called the Ventus cameras. All of the product names that we use in our company are oriented around the word wind, because in Hood River, Oregon, on the Columbia River there, it's very well known for kiteboarding and windsurfing. And the state parks and everything else around that area all utilize those names, so we borrow those names as well. But our camera technology uses what's called a hot midwave infrared detector. And HOT actually stands for high operating temperature. So for many, many years, when we first started using midwave cooled infrared cameras, they were mainly based on a material called indium antimonide or mercad telluride. And those materials had to be cooled to cryogenic temperatures, about minus 200 degrees centigrade or 77 degrees Kelvin. So over the last 5 years, the United States defense industry helped pay for the development of new detectors. And so we've been at the forefront of being able to implement that into our cameras. So the high operating temperature just means that the sensor is now operating at about 150 degrees Kelvin versus 77 degrees Kelvin, or about minus 100 degrees C versus minus 200 degrees C. The benefit of that is that the integrated Dewar cooler assemblies are much smaller, they're lower power, they're lighter weight. And it was with that in mind that we developed the Ventus, and we really specifically wanted to target being able to utilize the systems for drone or UAV, crewed, uncrewed type of systems, and handheld portable products to help miniaturize the technology over what it had been previously for the previous 20 years. So this was a really huge technological jump. And the other thing that we did is we introduced the technology for the first time with a VGA resolution sensor, 640 by 512. Everything to date had always been quarter VGA or 320 by 240 resolution. So by doing this, we were able to increase the resolution. You get 4 times the number of pixels. We have better sensitivity. So the whole goal of that is to be able to see smaller leaks at further distances. And what we see coming, in the future is then moving to high definition. So moving out to 1280 by 1024 type of sensors. And again, with those same things in mind about being able to detect and visualize smaller leaks at greater distances. The other thing about the high operating temperature sensors is the type of coolers that we use versus what we were previously using had limited life as far as how many operating hours they were generally rated for, which was about 8,000 to 10,000 hours. Today, with these high operating temperature midwave sensors, we've increased that. We've doubled that to 16,000 to 20,000. And now some of our newest cameras are employing coolers that are going to last about 35,000, 36,000 hours. This is super important because as we start looking at fixed mounted continuous monitoring, the biggest concern by industry is having to service the product on a frequent basis. And what we're trying to do is get in front of that so that once you install these types of systems in a permanent application, monitoring 24 hours a day, 7 days a week, 365 days a year, that you'll be able to have that installed and be able to run for 2 years, 3 years, 4 years, and eventually 5 years without having to do any maintenance. And so by having this type of technology, it enables us to be able to achieve those goals. These are the detectable gases. This is inside of the OGI cameras is a narrow bandpass cold filter. So we take the mid-wave infrared region, which is typically around 3 to 5 microns. We put a cold filter inside of the Dewar section of the camera, and it's a narrow band, and it's basically narrowed down to about 3.2 to 3.4 microns. It's where all of these enes and anes basically emit or absorb at, and that is how we're all able to visualize the gas. Okay? And then the second part of the equation is then having this delta T that was mentioned earlier in the rule. And that is you want some delta T between the gas and that background, and that helps you better visualize that relative to a warmer or a colder background. Typically, our cameras are able to discern that down to much lower temperature delta Ts than the 5 degrees that's being specified in Quad OB. We're generally down to a 1 degree, 2 degree centigrade kind of delta T. And we also have a lot of image processing capabilities that help enhance the contrast of the image, and so that we are able to kind of be able to reach out and see these smaller leaks again at further distances. So here's some applications that you're probably familiar with, but maybe some of them are not. There's some new things that are happening in the industry, and this is one of them. So all of our products are cameras as components, and what we do is we enable technology partners to create finished solutions. So everything that we have basically, and when you come by our booth, you'll see they're all open frame configuration with the electronics exposed. But all of our customers take our products and they integrate it into something that becomes a finished used good. This is a new product through a company called ChampionX that's located here in the Houston area. Many of you may know of ChampionX as a chemical type company, been around for over 100 years. And they've doubled down on emissions. And they have created a whole business unit basically built around that. They've been acquiring companies. But also they have individuals that really understand the OGI technology, really one of the foremost authorities and kind of the grandfather of the OGI. His name is David Furry. His company was purchased by ChampionX. So what's unique about this particular camera is it's designed specifically to meet Quad OB, C, and Appendix K. And it has within it a positioning and navigational system. So you take all of your assets that you may have in SAP or JD Edwards or Oracle, whatever CMMS system that you have, you upload all of those assets, and everything is geotagged at your facility. And with the handheld camera, with this positioning system, which is called a V-SLAM technology, when the operator takes the camera and holds it up to their eye, what it does is it creates and puts pins on every asset in the field of view that has to be scanned. Those pins are in white, basically, at that point in time. Then once you dwell on the target for 5 to 10 seconds, whatever your standard operating procedure will be, it will turn the pin to green that indicates that it has been scanned. So for traceability and auditable reasons, now you know that the person actually looked at and scanned the piece of equipment. And the other part of it is then if there is a leak, that pin can turn to a caution or a critical, a yellow or red color, basically. So this is something very unique and very innovative. It adds quantification capability. It is certified for ATEX certification, Class 1, Div 2. And these are just some new things that are happening within that, all based on the type of sensor that we offer. There's another company down on the floor there called MFE Inspection Solutions. And they've done a different kind of a version of the camera and using our product in a multiple use kind of a way, where they have a quadruped robot from Boston Dynamics called Spot, and they have the camera, the OGI camera, integrated on that with an acoustical device, And that allows them to be able to listen for the leak, where the camera actually visualizes so you know exactly where the point source of the leak is, and doing autonomous routes using the Boston Dynamics quadruped. So you can then remove it with a quick release and then make it into a handheld system, and the product is actually controlled just by an Android smartphone. Super slick, very lightweight, and it's got a long life battery that lasts about 4 hours on it. And then everybody's familiar with a lot of the drone platforms that you see down there, and our product is integrated on many different ones. In these slides right here, this is a company called FreeFly. It's a product called Astro. A couple of months ago, well, just about a month ago, Sony has decided to jump into the business. They have a product called the AirPeak, and they are going to be in the industrial inspection business, and they have integrated our OGI camera onto their platform with a visible light camera and an optional TD loss laser. Also down on the show floor is a drone-in-a-box solution from a company called Percepto, based out of Israel and with significant operations here in the United States. And in the bottom left-hand corner is a company over in Europe called Evolve Dynamics. And then the most used drone probably in the world for industrial inspections, the DJI M300 and the previous model, the M210. And then here coming up in the future with the introduction of their new M350, you'll see the camera integrated onto those platforms as well. And again, those will be combined typically with TD loss, sniffers, and in some cases, people are also working on doing this optically, doing quantification optically and not using a sensor, just using the image itself. Because of limited time, I'm not going to go through some of these. Just again, some of the aerial footage that I think everybody has seen. The advantages of the UAVs are the ability to cover large areas in a very short period of time. To be able to do that at varying height, we developed this mode called a gas enhancement mode that actually colorizes the gas plume, makes it easier for the human eye to be able to ascertain where the leak is actually coming from. But the sharpness of the clarity of the image is really significant, and it's making operators, jobs and being able to find these kinds of emissions a lot easier and faster. We're also doing manned systems as well. This is probably one of the most mature applications, integrating them into stabilized gimbals and flying these on helicopters and on fixed-wing aircraft. Again, here you're not having to deal with beyond line of sight issues at this point. So this is a very viable way, especially to do, very significantly large areas or linear assets like pipelines. So here you're seeing kind of overlays of the OGI onto the visible light with laser rangefinders that precisely indicate exactly where the leak is and at what distance it is, besides seeing where the leak is in itself. Okay? And again, for traditional pipeline patrols that people are doing for right-of-way inspections now, we have companies that are integrating these onto like Cessna aircrafts, and then larger aircraft, UAVs to come that'll be more VTOL oriented or fixed wing as we get waivers for beyond line of sight. And then, as I had mentioned a little bit earlier, the quadruped type of robots, really believe that this is going to be, a significant area of growth for OGI and their ability, with all the different manufacturers that are coming out for both tracked, wheeled, and walking robots. And the last slide I'll do here is on fixed-mounted continuous monitoring type of applications. And so here is where you have permanent mounted. And the things to note here is, again, with this technology that we're using for a long life cooler to improve reliability. But the other thing that we're working on is a way to because as companies want to scale and be able to do this continuously, the state of Colorado, for instance, is kind of setting new standards. Any new well pad that goes in as soon as you start putting a drill bit or anything into the ground, you have to start monitoring it to when the well comes in through its completion process. And then 6 months after, you have to monitor that site 24 hours a day, 7 days a week, 365 days a year, and you just can't do that with any other technology except fixed mounted. And so this is where, as we see these sites, grow in size and complexity, but because of the cost of the sensors, we're working on new technology to help lower that and increase the reliability and the life of that. So I'm going to stop there since my time's up. Anybody have any questions? Yes, sir.
Jeff, thanks for your talk.
Yeah.
You talked about, You talked about your new technology, and thanks for all the description of that. Is that ready? Is that already deployed, or are you still developing
No,
it?
we're still developing it. Right now, the goal is we're deploying it in the Permian, and for this summer, we'll be testing it basically and making sure that it's going to work the way that we believe. It'll be much miniaturized. It's a non-cooled technology, but it is still an imaging technology. It's going to be used for methane only. It is not for all of the other hydrocarbon gases, and it's going to have high reliability, minimum of 10 years, and then try to get the cost down. But we've done all the, I guess you call it, experimental testing at our facilities and outside with stage leaks. Now we got to go put it into practice. So once we have that at the end of the summer, then we'll be talking a lot more about it.
Okay, thanks.
We got a question in the back. Yeah. Just real quick, what kind of reporting software or deliverable is available for these systems? Is it PDF or recorded format?
Well, so it depends on kind of the end use case, but what we supply what are called software GUIs, or graphical user interfaces, SDKs, and API protocol. Because people want to be able to take our product, they're integrating it into all these solutions, and we have to be able to give them the command set, basically, so that they can control the product. And then we deliver all different types of interfaces so that they can stream the video data to however that they want to present that to the world. So we have, from USB interfaces, H.264, 265, IP video streams, gigabit Ethernet, MIPI, all these different kind of video outputs. But for us, as far as we don't have a kind of an in-product solution that we deliver as a report, because again, our product is more considered like an OEM product that somebody's going to take and integrate into something else. So we have to give them all the hooks and capability to be able to do that.
Another question. Make you run all the way to.
I told him I'd get my work.
I know, right? That integration with Spot was really interesting. Some of our more regulated lines, they require sight, smell, and sound.
Yeah.
And so I was wondering if, even though the dog can't smell, but the imaging with the sound, does that satisfy the EPA requirements?
So there is definitely, so the approach that people are going to have to take is you'll have to apply for a waiver to the EPA. That is a part of what B and C, if you can prove your method, you have a standard operating procedure that meets essentially the minimum requirements of the letter of the law, they will make exceptions. And so that is going to be the key. And one of my biggest messages that we're trying to stress to industry is the rule pretty much specifically focuses on handheld, ground-based inspections, right? But everybody knows that that is not the only method, and the EPA realizes that as well. But when they started writing this, and that's why there's so many comments, thousands and thousands of comments, because People want to use other technologies. And so the EPA is going to be very open to listening. So I think the answer to the question is, you know, something like SPOT is very powerful because it's like a pack mule, and you can put all kinds of sensors on it. You know, one of the ways that they're meeting the ATEX and class rated areas now is they're putting the LELs on SPOT, so as soon as it sniffs in something, they can either have it power down right then and there, or it can be removed from the area. So all of these things are happening in real time, and you know, so maybe they will be able to sniff and smell.
Awesome. Any other questions? Anybody else? Okay, I guess that's it. Thanks, Jeff.
All right, thank you.